Day one, we are going to be graphing linear inequalities into variables, aka guys, we're going to be just graphing lines again. And today, though, they're going to be inequalities, so there's going to be like a little something special about them. But I feel like we do okay with graphing lines, so hopefully this shouldn't be too tricky. Honestly, this should be easier than the last stuff we did, than like the elimination and substitution. That stuff's hard. This should be a little bit better. So first thing, let's review our inequality symbols. Remember, I want to hear from you guys. It doesn't do you or me any good to just talk, to a screen and have you guys not participate. So let's try to remember our inequality symbols. Okay, thanks, Bailey. Yeah, I figured. It looked like he was frozen. He might just need to maybe try disconnecting and reconnecting that Wi-Fi. All right, so who can refresh our memory? What does this symbol mean as an inequality? This first one here on the left, who remembers what that means? Yeah, good, that is less than. So this means less than. Good, somebody else, what does this symbol mean? Very good, that is greater than. What about this? What happens when we have a little dash underneath it? Yeah, good. This is less than or equal to. And then last one, somebody else. What does this symbol mean? Yep, very good. Greater than or equal to. These are all things we're going to have to know for today. So greater than or equal to. Good. So a solution to a linear inequality. Remember when we were doing our elimination and our substitution before? Our answer would be an ordered pair. Same kind of thing happens here, or like a coordinate point like x comma y. A solution to a linear inequality in two variables is an ordered pair and remember, an ordered pair is just like x comma y that makes the inequality true. So what we're going to do is just decide if an ordered pair here is a solution to the inequality. So we're going to practice substituting in values. If you have a calculator out, I would grab one out. Okay, thanks for letting me know, Asia. Hold on. Okay. Sorry, there was an announcement. Okay, so tell whether the ordered pair is a solution of the inequality. So we are going to just practice plugging these points in, or these numbers in, and simplifying. So again, if you have a calculator out, I would grab one out or use the calculator on your computer. So remember, what this means is we're just going to plug our numbers in where they need to go here. So if this is a coordinate point, remember this is your x, this is your y. So we're going to plug -1 in where we see x, and we're going to plug 9 in where we see y. Right? We're just going to plug those numbers in. If you want, use your parentheses. I know that that's helpful. So we're going to have 2 and then parentheses plus, and then parentheses is less than -3. So that's going to help us plug what we need to plug in. So 2 times x. What's our x value that we are plugging in? Someone take a look and let me know. What is our x value, Jake? -1. So 2 times -1 plus, and then our y value, and then someone else, what's our y value that we're plugging in? 9. So we just have 2 times, oh, Lynn, you're here. Hi, Lynn. We have 2 times -1 plus 9 is less than -3. So what we're going to do is simplify on the left and figure out, is that in fact less than -3? So what would be my first step here with simplifying now? Yeah, good. We're going to multiply. We're going to distribute. So that's that 2 times -1. So 2 times -1 is going to give us -2. Now, if you look at this plus 9, is there any number on the outside there to multiply it by? No. So do I need to worry about multiplying my 9 by anything or distributing over here? No. So I'm just going to bring my 9 with me. Is less than -3. Now we got to simplify one more time. -2 plus 9. Somebody tell me, what is -2 plus 9? Come on, guys. What's -2 plus 9? 7. And 7 is less than -3. So what we have to decide is if that's true or false. Do we think 7 is less than -3? Yes or no? No. So is this ordered pair a solution if it gives us something that's not true? No. So we would say not a solution. Okay, so we're just going to plug it in, see if it's true or not. So let's try that now on number 2. So remember, this is your coordinate point, which is an X and then a Y. So we are going to plug 2 in where we see X, and we're going to plug in -2 where we see Y. I would probably rewrite it with your parentheses. So X, so put parentheses, minus 3 times parentheses is greater than or equal to 8. And now we just need to plug things into the appropriate place here. Asia, what are we plugging in place of X here? The 2. So we're going to have 2 minus 3 times our Y value. Annalise, what are we plugging in for Y? -2. And now we're going to simplify on the left. So what do you guys see here that can be simplified on the left? Think about your order of operations. What should we do first? Yeah, exactly. If we look at this first, you guys might be like, oh, well, parentheses. Okay, good. Well, parentheses, this first 2 doesn't have anything going on. So I can't do anything with that. I'm just going to bring my first 2 down. But then here, Annalise said we need to distribute, which is true because we have a number outside of our parentheses. Bailey, what's -3 times -2? Yeah, Bailey, what's -3 times -2? You're thinking adding. We're multiplying. So a negative times a negative is a positive, and then 3 times 2 is, yep, +6. So 2 plus 6 is greater than or equal to 8. So now we just got to do one more simplifying step. And then Kaysen, what's 2 plus 6? Or not. Dallas, what's 2 plus 6? 8. So we got 8 is greater than or equal to 8. So we have to now decide, is that true or false? What do we think, ladies and gentlemen? Is 8 greater than or equal to 8? Yes, this is absolutely true because of the or greater than, right? What if it just said 8 is greater than 8? Is 8 greater than 8? No, but because it has the or equal to, that makes it work. So we would say that this is a solution. Good. All right. Good. I'm glad, Dallas. I think you're going to find this stuff a lot easier. Substitution and elimination can be hard, especially I feel like that's hard to learn through a Google Meet. You know what I mean? I think we all would have done a lot better with it if we were in person. All right, so let's take a look at number 3. We got negative 2x minus 3y is less than or equal to 15. So remember, we got our x, we got our y. So we are going to plug 5 in place of everywhere we see x. And we're going to plug negative 7 in place of where we see our y. So I would put your parentheses again, negative 2, parenthesis, minus 3, parenthesis is less than or equal to 15. So now let's just plug in our numbers to the appropriate places. We have negative 2 times x. Hayden, what am I going to plug in place of my x? Yep, we're going to have negative 2 times 5 minus 3 times my y value. Jake Sanders, what's my y value that I need to plug in? Yep, negative 7. And now we need to simplify. Jesse, what do you think I could simplify first? Think like your order of operations. Is there anything I could maybe multiply? You there, Jesse? Okay, maybe Jesse stepped away from his computer. Corey, what do you think I could simplify? Okay, well, that's fair. So think about your order of operations, Corey. You see where we have these parentheses here? Is there anything I can do with a number when you have a number outside of a parenthesis and a number inside? Do you remember, do I need to add, subtract, multiply, or divide these? Yeah, so I can actually multiply my negative 2 times my 5 and my negative 3 times my negative 7. Does that kind of make sense, Corey? Oh, okay. Yeah, no, so we just need to here, since you have your parentheses and numbers outside, you just got to multiply. So negative 2 times 5 is negative 10. And then negative 3 times negative 7 is positive 21. Is less than or equal to 15. So then let's simplify this. Lynn, what's negative 10 plus 21? Yeah, 11 is correct, Lynn. So 11 is less than or equal to 15. And then we just got to decide if that's true. So now everybody, do you think 11 is less than or equal to 15? Yes or no? Yeah, definitely. 11 is definitely less than or equal to 15. So this one works. So we would say it is a solution. Got your Wi-Fi issue fixed, Alex? Good. All right. You only missed the first few, and it's pretty easy to catch on to. We're basically plugging in numbers and seeing if it works or not. Okay. All right, so number 4, last one like this. So we have x plus y is greater than 0. So here's our coordinate point, negative 2, 2. So here's our x, here's our y. So we are going to plug negative 2 in where we see x. And we're going to plug 2 in where we see y. So we have x plus y is greater than 0. And I just put my open parentheses so we know exactly what we're plugging in where. So Nick, what do I need to plug in place of my x? Yep, -2 plus my y. Mason, what am I going to plug in place of my y? +2. And now I just need to simplify. So here, we might see the parentheses, but do you guys see anything that we can multiply? No, because there's nobody outside of my parentheses. So if you want, if it helps you, you could just drop those. And this is actually just -2 plus 2 is greater than 0. And can someone tell me what -2 plus 2 is? 0. Yep. And is 0 greater than itself? No. 0 is not greater than 0. You would need the or equal to underneath. So this one is not a solution. Good. Any questions about that, guys? Okay. All right. So next thing we're going to get into is the actual graphing part. So how to graph a linear inequality in two variables. Don't let the in two variables part confuse you. We're basically graphing a line, except now instead of, it kind of is going to look like this, except now instead of an equal sign, we're going to have a greater than, less than, greater than or equal to, or less than or equal to. So we have basically a two-step process here. First thing is we're going to graph what's called the boundary line. That's just a fancy word for graph the line. So you would first graph the line x minus 2. So like in this situation, you would have a y-intercept at -2, so you'd put a dot there. And then since there's nothing in front of the x, that means it's a 1, so you'd have a slope of 1, so you'd count up 1 over 1. Now you'll notice, though, it's telling us we either need to use a dashed line or a solid line. That's one of the little things here that's a little different. We are going to graph a line. Sometimes it's going to be a solid line. Sometimes it's going to be a dashed line. And that's going to depend on what your inequality symbol is. Do you guys remember when we graphed our regular old inequalities and we would have to graph like a little number line and you would have your open circle, shade to the left, or maybe you'd have a closed circle, or I'm sorry, closed circle, shade to the left, open circle, shade to right, things like that? No? Uh-oh. You do or you don't, Annalise? Okay. Alex says no. Alex, I feel like I remember we did this and you were pretty good at it. Oh, okay. Gotcha. Gotcha. So with these, remember what we did before is if we had an open circle, that would mean we would use our greater than symbol or our less than symbol, the ones without the bar underneath. Sounding more familiar? Okay, good. We would use our closed circle if we had the or equal to, right? Because it worked. This is going to be really similar to our dashed line versus our solid line. We use our dashed line in the same time at the same places we would use like an open circle, and a solid line at the same times we would use a closed circle. So a dashed line kind of means it doesn't necessarily equal that. So that's when we would use, so we would use a dashed line if we're dealing with greater than or less than symbols. We would do a solid line if we were dealing with greater than or equal to or less than or equal to symbols, like this. Okay, so that's how that works, very similar to before. Then, just like when we did those, I'll draw that again, just like before, maybe we had an open circle and we shaded to the right. Remember, that was based off of if it was a greater than or a greater than or equal to, you'd shade to the right because it was more. If it was a less than or a less than or equal to, you'd shade to the left because you'd need a number smaller. Same idea here, except our lines, we're not shading left or right. We're going to either need to shade above the line we draw or below the line we draw. And that's, again, going to be based on the symbol. we're going to shade above. Think above sounds like more, right? If something's above it, it's more than it. So we're going to shade above if we use a greater than or a greater than or equal to, or a greater than symbol. Because think greater, more, above. Shade below if it's less than. So a less than or equal to, or just a regular old less than. Because again, think less than, think smaller numbers, so you shade below. Okay. And if you're not sure, we can always test a point. But I think most of the time we end up being okay with where to shade. All right, so, oh, and one other thing I want to mention is what might be different if we have a line that's vertical, because sometimes you might have to graph a vertical line. So if you have to graph a vertical line, if we're dealing with like more than, values that are more than, you would actually shade to the right because that's where your bigger numbers are. And if it's less than, you would shade to the left, but we're going to see that in just a second, actually. So that's easier to apply when you're actually just doing it. So we're going to do that right now. So graph each inequality in our coordinate plane here. So we have y is less than or equal to 2. So we haven't done this in a second, but this is like vertical and horizontal lines, because do we have a full y equals mx plus b type of equation here? No, we don't have a full one, just a partial equation. So we have y is less than or equal to 2. So all I have is this number 2. So what you're going to do on your y-axis, remember we go to 2 and we put a dot there. So go to 2, put a dot. Then we need to decide if we would want a vertical line or a horizontal line. Which one do you guys would think would make most sense in this situation? So if we put a vertical line, isn't that just going to line up perfectly with our y-axis? Yeah, so would there be any difference between like y is less than or equal to 2, or y is less than or equal to 5, or y is less than or equal to -10? Wouldn't they all kind of look the same if that's what we did? Yeah, so instead, we want to draw a vertical line because there's not already a line there, right? If we draw it here, there's already a line there. We don't want to draw a line over our other line. So we're going to draw a line through 2. Now, here's where our little process, our 2 steps that we just learned up here come into place. This is a less than or equal to symbol. So if you need to look back, if we have a less than or equal to, what do we think? Should we use a solid line or a dotted line? Yeah, very good. If this is our symbol, then this means we need to use a solid line. So we are going to put a solid line through 2, just like this. Okay. Now the next question is, where do we need to shade? Well, this is y is less than 2. So if something's less than, it needs to be smaller than it. So if something's smaller, do you think we should shade above or below if our answers are smaller? Below, exactly. If it's less than, our answers are smaller, so you would shade below. So I normally, like if I'm writing this out in person, I normally use like a pen or like a highlighter, but I'm just going to use my little highlighter function here. And you would literally take your pencil or your pen or your highlighter and you actually shade below that line. It doesn't have to be perfect shading. I just have to be able to recognize that you shaded there. So you graph your line and you shade on one of the sides. Okay. Do we have this one done? Can I move on to number 2? Okay. So number 2, we got y is greater than -1. So again, y is greater than -1, so we're going to put a dot on the y-axis and -1. Now, this is just like before. Should I draw a vertical line or a horizontal line? It would be. Yep, it's going to be horizontal, just like before. Now, should that horizontal line be solid or dotted? If we have a just a greater than symbol, what do we think? Yeah, definitely is going to be dotted. So this means it is going to be dotted. So through -2, we're going to draw a little dotted line here. Do the best you can. I just need to be able to see, that there's the little spaces. So there's my dotted line. And then this is y is greater than -1. So greater is like more. So if it's greater than, do you think I should shade above my line or below my line? It would. Yeah, because it's greater than. Greater than is like more. So I'm going to shade above, just like that. So again, graph your line, decide if it's solid or dotted, then either shade above or below. If it's greater than or equal to, shade above. If it's less than or equal to, shade below. All right. How do we feel about this so far? Okay. All right. Let's go on to 3 and 4. We only have really just a few examples. They don't take very long. Okay, x is less than -4. What's a little different about this one versus what we just did? Anyone see what's a little different? Here, I'll zoom out. Yeah, before it was y's, now it's an x. So if before it was y's and we had a horizontal line, what do you think is going to happen when it's an x? What do you think? Yeah, exactly. If when it was y, it was horizontal, when it's an x, it's going to be vertical. So let's see what that would look like. So x is less than -4. So in this situation, it's x is less than -4. So we need to put a dot at -4 on the x-axis. That's the big difference there. Then if I'm on the x-axis, would it make more sense to draw a horizontal line or a vertical line? What do we think? So it's going to make more sense to draw a vertical line because a horizontal line, there's already a line there. Our x-axis is already there. We don't want a line laying on top of another line. So we're going to need a vertical line. So take a look at our symbol here. If this is our symbol, should my line be solid or dotted? Yep. So this one, if it's less than, it's going to be solid if you have the bar underneath. Does this one have the bar underneath, Dallas? No. Oh, that was Alex, sorry. Yeah, so this one is going to be, no, that's okay. That's why we're learning it. So this one's going to be dotted. So we are going to have a dotted line going vertically through our -4. Okay. So there's our line. Now we need to decide where to shade. Well, can someone tell me what this symbol means again? You can look at the front if you need to. What's that symbol mean? Does it mean less than or does it mean greater than? Yeah, this means less than. So less than, should we think smaller numbers or bigger numbers? Smaller numbers. So if we're dealing with smaller numbers, do you guys think we should shade on the left or on the right? On the left, because isn't that where our numbers are going down? This This one's a little trickier because it's not above or below, but again, think less or more. We would shade on the left here because we want smaller numbers. If it was greater than, we want bigger numbers, we would shade on the right. All right, and then let's take a look at 4, and then the others are in y equals mx plus b form, and that'll be a little bit more standard for this. So we have x is greater than or equal to 3. So somebody tell me, where do I need to put my dot if we have x is greater than or equal to 3? On 3, on the x or the y-axis, Annalise? Yep, put a dot at 3 on the x-axis. All right, good. Somebody else, is this going to be a vertical or a horizontal line? Yep, this one's vertical. And then if our symbol is a greater than or equal to, should my line be solid or dotted? Ooh, we got both responses. So if it's or equal to, let's go back and look. If it's or equal to, we should use a solid line, because that's like when we had like a closed circle versus an open circle. This would be a closed circle problem, so we use a solid line. Does that make sense, Asia? Okay, so we're going to use a solid line. And then if it's a x is greater than or equal to, we want numbers that are more. If we want numbers that are more, should I shade on the left or on the right? Yep, that's where my bigger numbers are. We are going to shade on the right. Good. Any questions or things you need me to re-explain on the ones we've done so far? We feel okay about those ones? Okay. All right, let's go on to 5. All right, so we have y is less than or equal to negative 2x plus 3. So remember, this is in y equals mx plus b form. So this is like when we graphed and saw where our lines cross. This is just graphing basic lines. Remember, first graph your y-intercept, then count out your slope. So if we have y is less than or equal to negative 2x plus 3, who can tell me what my y-intercept is here? 3. So very good. I'm going to put a dot at 3 on my y-axis because that is my y-intercept. Somebody else, what's my slope? Yep, negative 2 or negative 2 over 1. Asia, do you remember how you'd count out a slope of negative 2? Oh, that's okay. Yeah. Yeah, very good. If you have a slope of negative 2, that's like negative 2 over 1. So from your y-intercept, count down 2 and write 1. And I would do that at least a few times. Down 2, write 1. And now you have your line. I'm going to use my little line thing here because that just looks better. Okay, so here is the line. If I can get it in the right spot. There we go. All right, so there's my line. And then if this is a y is less than or equal to, what do you guys think? If it's less than or equal to, do I need to shade above or do I need to shade below? Oh, wait, actually, before, I almost forgot. I almost messed up here. Does this line need to be solid or dotted? Yes, this line needs to be solid. So did I graph it correctly? Yeah, I got my solid line. I'm good. All right. So this needs to be solid, and if it's less than or equal to, do I need to shade above the line or below the line? Yeah, less than means shade below. So now some people, when your line is slanted like this, they have a little trouble deciding where above versus below is. Think of like your line is like a hill, right? If we're shading above, we shade above the hill. If you're shading below, you shade underneath the hill. So we're going to shade underneath it. So think like underneath versus above. So this is less than, so we're going to shade underneath our line here. Okay. So again, graph your line, see if it needs to be solid or dotted, and then see where you need to shade. All right, number 6. We have y is greater than 2 over 3x minus 1. So somebody else, because I already heard from Annalise about this, what is my y-intercept here? We have y is greater than 2/3 x minus 1. Let's see. That's okay. Yeah, Mason, what's my y-intercept going to be? -1. So let's put a dot at -1. Then our slope. Somebody else, what's our slope? 2 over 3. Good. So we have 2 over 3. Nick, how do you think I'd count out a slope of 2 over 3? Yep. Yep, very good. We go up 2 over 1, 2, 3. And we can do that again, up 1, 2 over 1, 2, 3. Good. Now our symbol here is just a greater than symbol. So if it's a greater than, there's no bar underneath. Jake Sanders, do you think I want a solid or a dotted line here? It would, yep. If it's just, because think, if it's greater than, that would be an open circle, which is like our dotted line. So this is going to be dotted. Jaden, do I see that you're here now? Well, I mean, just because he's logged in, though, doesn't mean he's actually here. Jaden, you have to respond, or else I'm going to think you're just a figment of my imagination. All right, so thank you, Jaden. So we are going to have a dotted line through here. All right, so there's our dotted line, and now we got to decide where to shade. So this is a y is greater than symbol. So if it's greater than, Dallas, if it's greater than, do you think I would shade above the line or below the line? Above, good. So if it's above, what do we think? I just want to make sure we understand. Do you think above would be here? Or would it be here? What do we think, guys? Yeah, the purple, yeah, that's above. And I know for some of you that might sound like a silly question, but trust me, I've seen people do it wrong before. So yes, above, think like on top of the hill here. Good. Any questions yet? How are we feeling about this? Do we feel better about this than we did with the last stuff? Okay. All right. 2 more, and then I want to take just a quick look at the homework, see what's on there, and then we'll be done actually, and you guys can get started on your homework. Olivia, are you there yet? Because I still haven't heard back from you. Okay. All right, y is less than 1/3 x minus 4. Y is less than 1/3 x minus 4. So what is our y-intercept? Aaron, you're here now. Aaron, what's my y-intercept? -4. Yep, so we're going to put a dot at -4. All right, Jaden, what's my slope? Yep, just the 1/3. We don't have to worry about the x part, but yeah, it'd be 1/3. Jaden, do you remember how you'd count out a slope of 1/3? Yep, yeah, exactly. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And remember, guys, if you're ever doing that and it won't fit, you can do the opposite. Down 1, left 3. Good. So now we have this symbol here, just a regular old less than. Hayden, if it's less than, do you think we should use a solid or a dotted line? I did. Do you think we should use a solid or a dotted line? That's okay. Yes, this should definitely be. No, that's okay. I know that happens. So yeah, this should be dotted. That should definitely be dotted. Good, and now we need to decide if we would shade above or below. So it's y is less than. So if it's less than, Jesse, do you think we would shade above or below? You there, Jesse? All right, Corey, what do you think? If it's less than, should I shade above or below? Below, good. Less than means we are going to shade below. Good. All right, and last one, guys. So are we feeling pretty good about this so far? Okay. Again, I can't see your faces, so I need some feedback. Okay. All right, number 8. Okay, thank you, Alex. All right, number 8, we got y is greater than or equal to 4x plus 2. 4x plus 2. Bailey, what do you think my y-intercept is for this problem? That's actually the slope part. So the part that's attached to x is your slope. So which part then do you think would be your y-intercept? The 2. Yep, so we're going to put a dot at the 2. Good. And then, Lynn, what's my slope and how do you think I count it out? Good. It is 4. Do you think I need to count up 4 or down 4, Lynn? Up. Good. Yep. So if it's 4, we're going to count up 4. 1, 2, 3, 4 over 1. And we can do that again. 1, 2, 3, 4 over 1. Good. And we have a greater than or equal to symbol. So if it's greater than or equal to, Alex, do you think we should use a solid or a dotted line? So that's okay. So sorry, what was that, Alex? Solid, yeah. And a kind of a little trick to try to remember it. Isn't there a line underneath this symbol? Yeah, so that's kind of a little trick. There's a line underneath, so you use a regular line. Oh, that's okay. So this is gonna be solid. So we're gonna have a solid line there. Good. And then I need to decide if we're gonna shade above or below. Now this line is very steep. So again, think of it like a hill. If we're shading above, we want to shade on this side of the slope. And if we're shading below, we would think of it like underneath. Okay, so again, think of it like a really steep hill. This you'd be on top of the hill, this you'd be below the hill. So if it's greater than or equal to, Annalise, where do I shade if it's greater than or equal to? Yep, good. We are going to shade above. Very good. Hey, guess what, guys? That's really it. Yeah. Alex, do you have a packet? Do you have your chapter 5 packet? Okay, I'm just wondering because since you're in the building, I mean, if you have your chapter 5 packet, you can write down all these notes in it. Because I was just thinking if you don't have a packet,